let me finish this. I made an editing mistake. This was supposed to kind of go up higher, but piecewise defined functions is something that trips some students up a little bit. So I want to talk about that with you. So, so check this out. I want you to imagine that we have a picture. Let's draw a picture here. This is terrible. Does anyone know what this is supposed to be?
This is America's map.
Yeah, America as yeah. And then I'm gonna cut my map into different pieces. So I cut it here. Let's just cut it in 3 pieces. Okay. So basically, what this is supposed to represent is supposed to represent a domain is the entire US. But your domain, we're chopping it up into 3 different pieces. So you got piece 1, you got piece 2, and then you got piece 3. And then what's going to happen is on each of the different pieces, we're going to take our function f of x and we're going to define it in different ways. So if it's on piece 1, maybe it's sine of x. If it's on piece 2, maybe it's x squared. And if it's on piece 3, maybe it'll be square root of x. Okay. So the way that we would define our function, I'm trying to draw a picture to help you understand it. But the way that we're going to define our function is we're going to write like this. We're going to say f of x is equal to, and then we're going to write each of the 3 functions. So it's going to be sine of x, x squared, and x square root of x. And this will be if x is in piece 1. This will be if x is in piece 2. This will be if x is in piece 3. Does that make sense? So the function is defined differently depending on where you are inside the domain. That's how a piecewise defined function works. Oops. Okay. So obviously we're not going to draw, maps like this. We're going to define sort of give a mathematical description. So the most famous piecewise defined function that we work with is absolute value. So this is important. And the way that this absolute value works is that it's a piecewise defined function. So we're going to split it up into 2 pieces. And instead of drawing a map, our domain is going to be like the real number line. We're going to cut the real number line into 2 pieces. So we're going to look at the piece where x is greater than or equal to 0. We're going to look at the piece where x is less than 0. Now, before I define the piecewise defined function of absolute value, you guys should all know what absolute value means already, right? Most students think of absolute value as make it positive. So if I said, what's the absolute value of -7? You guys would tell me, I hope, 7. If I said, what's the absolute value of 12? 12 is already positive, so you guys would just say 12, right? So how does absolute value work? How do we say make it positive? What does that mean? Well, this first piece This first piece right here says that x is already positive or non-negative. If it's already non-negative, you don't have to do anything to it. You just leave it. So if it's already non-negative, just leave it. Just put an x. The second piece, which is, the negative numbers. Oh, for the negative numbers, we want to make it positive. So how do you make a negative number positive? What do you do to turn a negative number into a positive number?
Multiply by negative.
Correct. So instead of writing x, we're going to multiply x by a negative. And that's going to be our piecewise defined function. Does that make sense? So when you think of absolute value, I know you think of it as make the number positive. But we're going to think of it as a piecewise defined function as well. So next class, we are going to, hold on. Next class, we're going to look at graphing, but I want to graph this one for you anyways. So when I go to graph the first piece, I only look at the positive x values. So I know that for those guys, it's going to be y is equal to x. And we know that the graph of y is equal to x looks like this. That's y is equal to x, right? But because it's piecewise defined function, I only want to graph the x greater than or equal to 0 part. So actually, I don't want to graph the entire left side of that line. So I come over here and I erase this guy. So it's okay if you graph the whole thing, but you got to erase the part that's outside of that state, that whole Eastern America or whatever. Okay. And then I go to graph the second piece. The second piece looks like this. This is y equal to negative x, right? It's a line with a slope of -1. We're going to review this next class, but let's pretend you remembered how to do that. What's the problem with this drawing that I've just written? There's a big problem when I look at this. Can you see? Can you see what it fails? Correct. It fails the vertical line test. So the right-hand side is not a function. But remember, we only want to graph this line on the pieces where it's defined. So this guy's only defined for negative values of x. So actually, we need to erase this guy. So when you do that, then you get the graph of absolute value, which is basically a V. This is one of our basic shapes.